Let's move on to the next part of the chapter, which is about midpoint formula. Now, before we start, let's revise section formula. Well, section formula said if a point P divides a line segment AB into M1 is to M2, we can calculate the coordinates using the section formula. Now, in case P is the midpoint, which means if AP and PB are equal, then what would be the ratio of M1 is to M2? Yes, it's correct. The ratio of M1 is to M2 would be 1 is to 1. So if you substitute the value of M1 and M2, you would get the midpoint formula as x1 plus x2 upon 2 and y1 plus y2 upon 2. So that would be your midpoint formula for a point which lies exactly in the center of a line segment. Let's revise one more thing before we start this exercise. This is about centroid. Now, centroid is basically, we've done this in grade 9. Centroid is a point of intersection of three medians of a triangle. A median, what is that? Median is a line segment which joins the midpoint of a side of a triangle to the opposite vertex. So each triangle will have three medians. It joins the opposite vertex to the midpoint of the opposite side. Perfect. And now let's look at the third median for this triangle that I've drawn here. And here again, these will be two equal points. So the centroid is, so all three medians are concurrent, which means they meet at one point. Let's name this O. Now, the midpoint formula and the section formula will help us calculate the coordinates of O. How? Let's look at this. One key factor about a centroid that it divides each median in the ratio 2:1. So each median in the ratio 2:1. Let me name them for convenience sake. Let this be ADB median, BEB median, and CFB median. So as per this, what it means is OA is to OD is equal to 2:1. OB is to OE is equal to 2:1, and OC is to OF is equal to 2:1. Now there are two specific methods of calculating the centroid. Method 1 would be first using midpoint formula, calculate coordinates of D. So if this is x1 and y1 and this is x2 and y2, you would calculate the coordinates of D using midpoint formula. So this would be x1 plus x2 upon 2 and this would be y1 plus y2 upon 2. So this is how you would get the coordinates of D. Now I know that the centroid divides the median in the ratio 2:1. So second time you will apply the section formula. So first you apply midpoint formula to get coordinates of D and then apply section formula with the ratio m1 is to m2 is equal to 2:1 and this will give you coordinates of O. There is an easier method 2, which is a simple formula, but that's something that you will need to remember, which is coordinates of O are x1 plus x2 plus x3 upon 3 and y1 plus y2 plus y3 upon 3. Now what are x1, x2 and x3? x1, x2 and x3 are the coordinates of the three vertices. So you add the coordinates of the x coordinate of all three vertices and divide by 3. That'll give you the coordinates of the centroid. So now let's look at some questions. Question 1 says find the midpoint of the line segment joining the following points. So if this is the line segment joining these 2 points, midpoint will be given by the formula 5 plus -1 upon 2 and -3 plus 7 upon 2. So the midpoint will be 5 minus 1, that's 4 upon 2, and -3 plus 7, that's 4 upon 2, which means midpoint is 2, 2. Simple, isn't it? Yes, it is extremely simple as long as you remember one formula, and that's about it. Let's look at question number 2. Question number 2 says point A and B have the following coordinates, and this time the midpoint is given. Oh, so this is A, this is B, and the midpoint, let's say P, this is 2, 3, and this is 3, 5, and this is x, y. We need to find the value of x and y. So using midpoint formula, I know 2 comma 3 will be equal to 3 plus x upon 2 and 5 plus y upon 2. So let's take these two equations separately. It should get us some answer. 2 is equal to 3 plus x upon 2 and 3 is equal to 5 plus y upon 2. Let's cross multiply. It gives me 4 is equal to 3 plus x and 6 is equal to 5 plus y, which means x is equal to 1 and y is equal to 1. Perfect. So let's read the question. What do they want me to calculate? Find the value of x and y. Done. I've already found. Let's look at question number 3. Question number 3 says A, B, C are the vertices of a triangle ABC, and L is the midpoint of AB and M is the midpoint of AC. We need to prove that LM is equal to half BC. So let's first calculate the coordinates of L. So coordinates of L will be equal to 5 plus minus 1, that's 5 minus 1 upon 2 and 3 plus 1 upon 2. So that's 4 upon 2 and 4 upon 2, which means this is 2 comma 2. Let's calculate the coordinates of M. Your coordinate of M will be 5 plus 7 upon 2 and 3 minus 3 upon 2. That's 12 upon 2 and 0 upon 2. That's 6 comma 0. So M is 6 0 and L is 2 comma 2. Now let's apply distance formula. So using distance formula, let's calculate the length of LM and BC. So using distance formula, we will get ln will be equal to 6 minus 2 whole square plus 0 minus 2 whole square, the whole square root. This is 4 square plus 2 square, that's 16 plus 4, that's square root of 20, which is equal to 4 into 5, that's 2 root 5 units. Perfect. So therefore, ln is equal to 2 root 5. Now let's calculate BC. BC is equal to 7 minus negative 1. That's 7 plus 1 whole square plus negative 3 minus 1 whole square. The square root of this. So that's 8 square, which is 64. This is 4 square, that's 16. So this is square root of 18, which is 16 into 5. Yes, which means 4 root 5 units. Now let's give them some numbers. So this is 1, this is number 2. I figured lm is equal to 2 root 5 here. Number 4. So using 3 and 4, 2 root 5 is equal to half of 4 root 5. Therefore, lm is equal to half BC. Hence proved. Next question, question 5. Question 5 says P is the midpoint of the line segment joining AB as shown in the figure. Find the coordinates of point A and B. So we need to find coordinates of A and B. Now I notice that A lies on the y-axis and B lies on the x-axis. So we already have done such kind of questions. So let the coordinates of A be 0 comma y. This is because the x coordinate will always be 0 for a point on the y-axis, and for B let it be x comma 0 because the coordinates of the y coordinate will always be 0 for a point on the x-axis. So now we know that P is the midpoint, which means negative 3 comma 2 is equal to x plus 0 upon 2 and 0 plus y upon 2. Taking these two equations separately, I get negative 3 is equal to x upon 2 and 2 is equal to y upon 2. Let's cross multiply. It gives me x is equal to negative 6 and y is equal to 4. Let's see what do they want me to calculate. As per the question, find the coordinates of point A and B. Therefore, A is equal to 0 comma 4 and B will be equal to negative 6 comma 0. Perfect. Let's see if there's anything else. No. Let's do the next question. That's question number 7. These three are the vertices of a triangle. Find the length of its median through the vertex 3, negative 6. So we need a median which is being drawn from this vertex onto the opposite side, and we need to find the length of it. So let's give it some name for our convenience. Let's call it A and D, and this is the midpoint. So for first we will need to calculate the coordinates of D. So the coordinate of the point of intersection between median from 3 comma negative 6 and the line segment joining negative 5 comma 2 and 7 comma 4. So let's find the coordinates. This coordinate will be using midpoint formula, negative 5 plus 7 upon 2 and 2 plus 4 upon 2. So this will be equal to 2 upon 2 and this will be 6 upon 2. So this coordinate is 1 comma 3. So this coordinate is therefore uh, D is equal to 1 comma 3. Next part of the question, they say find the length. So now we'll use the distance formula. So using distance formula, AD will be equal to x2 minus x1 whole square, which means 1 minus 3 whole square plus y2 minus y1, that 3 minus minus 6, so that 3 plus 6 whole square. This gives me 1 minus 3 is 2 square, that's 4, and this is 9 square, that's 81, which means this is equal to root 85 units. Can I simplify this further? No. Therefore, length of median is equal to root 85 units. I can also find the root and give the answer as 9.22 units. You will also be given a square root table, which we've already done how to use. You can look at the answer from the square root table as well. Question number 10, it says A, B, C, D are the vertices of a quadrilateral given here. Find the coordinates of the midpoint of AC and BD and give a special name. So let's start. We need to find the midpoint of AC. So midpoint of AC will be equal to, using our midpoint formula, 2 minus 4 upon 2 and 5 plus 3 upon 2, which would be negative 2 upon 2, that's negative 1, and that's 8 upon 2, which means 4. So that's the midpoint of AC. Now let's find the midpoint of BD. So midpoint of BD, it will be equal to, let's add the x coordinates, so that's 1 minus 3 upon 2 and 0 plus 8 upon 2. So this is equal to, let's see the value. This will be equal to 1 minus 3, that's negative 2 upon 2, which means negative 1, and 8 upon 2, that's 4. So this is midpoint of BD. Now AC and BD are the two diagonals of this quadrilateral, and they are intersecting at the same point, which is dividing these two diagonals into equal parts. Right? So this is the midpoint of AC, and this same point, let's call it point O, is also the midpoint of diagonal BD. Now, what kind of special type of quadrilateral is this? Yes, we know this could be either of rectangle, square, or a parallelogram. So let's write, since the diagonals bisect at at O, therefore ABCD is a parallelogram. Now, what special type of parallelogram? Let's try and figure out, because this could have been, in our mind, we are clear, this could be a parallelogram, this could be a square, this could be a rectangle. So we need to figure out what else do we know. So there is one key defining factor between a parallelogram and a square and a rectangle. In this, diagonals are not equal, whereas in both of these, diagonals are equal. So now let's try and figure out if the two diagonals are equal. If the diagonals are equal, then we'll have to differentiate between square and rectangle. If the diagonals are not equal, then we will know that it's a parallelogram. So length of diagonal BD. So BD will be equal to, using distance formula, 1 minus negative 3, that's 1 plus 3 whole square, plus 0 minus 8 whole square, right? So this will be 4 square, that's 16, and this is 8 square, that's 64. So this is square root of 80, which means 8 into 10, that, oh, sorry, 16 into 5, so that's 4 root 5 units. That's your BD. Now let's look at the diagonal AC. AC will be equal to 2 minus negative 4, that's 2 plus 4 whole square, plus 5 minus 3, 5 minus 3 whole square. This is equal to 6 square, that's 36, and this is 2 square, that's 4, which means square root of 40, which means 4 into 10, which is 2 root 10 units. Now, since the diagonals are not equal, since diagonals are not equal and the diagonals bisect each other, therefore quadrilateral ABCD is a parallelogram. Right? So here we figured it is a parallelogram. It could have been a parallelogram, square, or rectangle. Finally, we can see it's only a parallelogram. Next question, question number 12 says ABCD is a parallelogram. The vertices of the coordinates of the three vertices are given. We don't know the coordinates of C. So let C be equal to x comma y. So let this be x and y. Any property of a parallelogram which we know, which will help us to solve this? Yes, we know diagonals of a parallelogram bisect each other. Right? So diagonals of a parallelogram bisect each other, which means this diagonal AC and the diagonal BD bisect each other, which means the point O, let's say if this is the point of intersection, O is the midpoint of BD as well as of AC. So let's use this property and let's calculate. Therefore, midpoint of AC is equal to the midpoint of BD. Apply the midpoint formula and let's look at this. So AC, midpoint of AC would be x minus 1 upon 2 and y plus 0 upon 2. And midpoint of BD will be equal to 1 plus 3 upon 2 and 3 plus 5 upon 2. Let's take these two equations separately. X minus 1 upon 2 is equal to 4 upon 2 and y upon 2 will be equal to 8 upon 2. Let's solve them separately. X minus 1 is equal to, this is 2 into 2 equal to 4, which means x is equal to 5. Perfect. And let's look at this. This will be 2 into 4, which means y will be equal to 2 into 4. Therefore, y will be equal to 8. Let's read the question once again. It says, find the coordinates of vertex C. Therefore, C is equal to 5, 8. Perfect. Let's look at the next question, question number 15. Question 15 says point PQR are collinear, so they lie on the same line. Q lies between P and R as per the diagram that rough diagram that I've drawn, such that PR is equal to 2QR. So PR is equal to 2QR, we need to find A and B. So if QR is X, so again, this is basically a part to total ratio. If QR is equal to X, PR is equal to 2X. So what it means is PQ plus QR is equal to 2QR. What it means is PQ is equal to QR, which means therefore Q is the midpoint of PR. That's what basically it means. So if this is the midpoint, then we'll apply the midpoint formula, which means negative 2 is equal to A plus 0 upon 2. This is the x coordinate. and the y coordinate of the midpoint, which is b, is equal to negative 4 plus 2 upon 2, which means negative 4 is equal to a, and b is equal to negative 2 upon 2, that's negative 1. Let's check what do they want. As per the question, they say find the value of a and b. So we've already calculated. A is negative 4, b is negative 1. Question 13. Question 13 says the points, these 3 points are midpoints of the sides of a triangle. Find the vertices. So the vertices are not given. So let the vertices be. A would be x1, y1. B is, so this is x1, y1. This is B and this is C. B be x2, y2 and C be x3, y3. So I know that this point is the midpoint of AB and this is midpoint of BC. So now using midpoint formula, 2 is equal to x1 plus x, oh this is x2, y2 and this is x3, y3. So 2 is equal to x1 plus x2 upon 2. Similarly, the y coordinate, which is negative 1, is equal to y1 plus y2 upon 2. Let's cross multiply. X1 plus x2 is equal to 4. That's my first equation. And y1 plus y2 is equal to negative 2. That's my second equation. Let's look at for BC. So this is for AB. Now let's look at for BC. Now the midpoint is given as negative 2 comma 2, which means negative 2 is equal to x2 plus x3 upon 2 and 2 is equal to y2 plus y3 upon 2. Let's cross multiply and I get x2 plus x3 is equal to negative 4 and y2 plus y3 is equal to 4. This is my equation number 3 and this is equation number 4. Let's look at the last side, which is for AC. This is the midpoint, which means negative 1 is equal to x1 plus x3 upon 2 and 4 is equal to y1 plus y3 upon 2. Let's cross multiply. So this is x1 plus x3 is equal to negative 2. This is my equation number 5 and y1 plus y3 is equal to 8. That's my equation number 6. Now for x coordinates, which I have 3 equations, for y I have 3, that's how I have total of 6, and I need to solve these 3 simple equations simultaneously. So my method of solving it, there could be many methods. I add them up together. That's my the method that I use. So let's add all of them up. X1 plus x2 is equal to 4. X2 plus x3 is equal to negative 4 and x1 plus x3 is equal to negative 2. Let's add them up. When I add them up, I get 2x1, I get 2x2 and I get 2x3. So that's 2 times x1 plus x2 plus x3 gives me 4 minus 4, that's 0 minus 2, which means x1 plus x2 plus x3 is equal to negative 1. So this is my equation number 7. Now I substitute values of some equations here. Let's try. X1 plus x2 as per equation 1 is 4. So put 1 in 7 and I get 4 plus x3 is equal to negative 1, which means x3 is equal to negative 5. Perfect. So put x3 is equal to negative 5 in, let's say, equation number 3 and I get x2 plus negative 5 is equal to negative 4, which means x2 is equal to negative 4 plus 5, that's 1. Now put which is what I've got x3, x2, I've got 1, x1. So put x2 is equal to 1 in equation 1 and I get x1 plus 1 is equal to 4, which means x1 is equal to 3. So I've got the coordinates of all x. Now let's do the same thing for y. Let's add all of them together. So y1 plus y2 plus y3 is given. Oh no, sorry, I have to first add them up. My mistake. I have to add them up. So I have y1 plus y2. That's my equation number 4. Sorry, equation number 2. This is equal to -2. Next equation 4 is y2 plus y3. That's 4. And then the last equation I have is y1 plus y3. This gives me 8. Add all of them up. That gives me 2 times y1 plus y2 plus y3. This is equal to 8 plus 4, 12. 12 minus 2, 10, which means y1 plus y2 plus y3 is equal to 5. Now put y1 plus y2. Where do I have that equation? That's 2. So if I put y1 plus y2 is equal to -2 in this equation, and I get -2 plus y3 is equal to 5, which means y3 is equal to 7. Perfect. And now let's put y3 is equal to 7 in 4. So put y3 is equal to 7 in equation 4. And what do I get? I get y2 plus 7 is equal to 4, which means y2 is equal to -3. Done. Now the third equation, which is y1 plus y3. So y1 plus y3 is 7 is equal to 8. Therefore, y1 is equal to 1. Let's read the question and check what do they want me to calculate. As per the question, they say find the vertices. So let's put them together. I don't have space here. So if I can take the liberty and write my answer here, you will write your answer in properly. So let's look at the answer. So vertex A is x1 and y1. So where is x1? x1 is 3 and y1 is 1. Thank you. B is x2, y2. So x2 is equal to 1 and y2 is equal to -3. And C is x3, y3. So x3 is -5 and y3 is 7. Next question, question 16. We need to find the coordinates of the centroid. So the coordinates, if you remember, is x1 plus x2 plus x3 upon 3, and similarly y1 plus y2 plus y3 upon 3. These are the coordinates of the centroid. So let's add them up. 7 plus 0 minus 1 upon 3 and -2 plus 1 plus 4 upon 3. These would be the coordinates of the centroid. This is 7 minus 1, 6. 6 divided by 3, 2. And this -2 plus 1, that's -1 plus 4. That's 3 upon 3, which is 1. So these are the coordinates of the centroid. Coordinates of centroid. Very simple. As long as you remember the formula, extremely simple. Let's look at question number 18. Question 18 says that this is a triangle and the centroid, the coordinates of the centroid, it lies on the origin. We know the coordinates of the origin are 0 and 0. So they want us to calculate the value of x and y. So again, using the formula, we know that 0, 0 will be equal to 5 minus 4 plus y upon 3 and x plus 3 minus 2 upon 3. I've just added x1, x2 and x3. And I've added y1, y2 and y3 divided by 3. So let's take these two equations separately. This is 5 minus 4, that's 1 plus y upon 3. And the y coordinate will be 0 is equal to x, 3 minus 2, that's 1. So x plus 1 upon 3. Let's cross multiply. So I get 0 is equal to 1 plus y and 0 is equal to x plus 1, which means y is equal to -1 and x also is equal to -1. Let's see what do they want me to calculate. They say calculate the value of x and y, which is done. So that's about it. This finishes this chapter for us, but let's look at some homework questions before we go. So homework for you from this exercise would be question number 6, 9, 11, 14 and 17. Thank you so much. Take care. Be safe.